Welcome back to the Network Engineer Diaries. It's your host, Jimmy Shaka. Today we're going to talk about static routes and route summarization. As you can see here, we have this network topology that consists of 6 routes. We have router number 1 here, router number 2, router number 3, 4, 5, and 6, the Internet Service Provider router. On the side, we have 2 offices, Office 1. At the bottom, we have Office 2. On the far left-hand side, we have Office 3. Let's try to see if PC1 in Office 1, if it has any connectivity to any of the computers over to the left-hand side in Office 3. Open the command prompt on PC1 from Office 1. Let's try to ping laptop number 7 on the far left-hand side in Office 3. Let's see if there's any connectivity between the 2 computers across the network. So ping 10.20.2.17. It should take a minute, but it's going to fail. As you can see, the first ping has failed, the second one has failed as well, and the third and the fourth should fail too. So the reason why this is failing is because the traffic is going from this PC here down to this router, and this router doesn't know how to forward the traffic across this network. So what we're going to do today is configure these routers to be able to forward the traffic across this network. And then towards the end, we're going to cover route summarization. The routing protocols are divided in 2 main categories. We have dynamic routing protocols, and then we have static routing protocols. Static routing protocol, you have to configure these manually, okay? But the dynamic routing protocols, once you have them set up, the router is going to decide which route to take depending on various variables like the bandwidth on the link or various metric parameters. Okay, dynamic routing protocols, it's a topic for another day. Today we're going to talk about static routing protocol. Back to our lab. Let's configure these names, the router names on the routers. Open router number 1, command line, go to the config, global configuration, enable global config, host name R1. So that's done. Do the same on R2. Host name R2. Do the same on R3. Enable config T. Host name R3. Same thing on R4. Enable config T. Host name R4. Okay. And then R5. Good. We have the names configured on all these 5 routers. Okay. Next, let's configure these IP addresses that we have on our network on these routers. So router 1 is connected to 4 different subnetworks. There is a 10.10.0.0/24 subnet mask network. There is a 10.10.3.0/24 network, and there is a 10.10.1.0 subnet, and then there's a 10.10.2 towards Office 2 network, subnetwork. Okay, there's 4 of them. There's 4 of them for router 1, and then router 2 has 2 subnets, this one and that one. Router 3 has this subnet and this subnet. Okay, router 4 has 4 subnets. This subnet right here, 10.20.2.0/24 subnet, and then that and this, and then the link to the internet service provider. Okay, let's start with R1. Go to interface fast 0/0. Okay, so what we're doing here is basically router 1 has 4 interfaces. There's fast Ethernet 0/0 towards router 2, and then there's interface fast 1/1 towards R5. And there's fast Ethernet 0/1 towards Office 1, and then there is fast Ethernet 1/0 towards Office 2. So we're starting with 0/0 towards the interface facing R2. Okay, all right. Fast Ethernet 0/0. Enter. IP address 10.10.0.1. Subnet 225.225.225.0. Enter. No shutdown. Remember, you have to say no shutdown on routers because by default routers do shut down interfaces, so no shutdown here. Okay, repeat the same on the other 3 interfaces. Fast Ethernet 1/1, 1/0, and then 0/1. Okay, let's do this real quick. Interface, let's start with the one towards Office 1. 0/1. IP address 10.10.1.1 255.255.255.0. No shut. Interface fast 1/1. IP address 10. What's the IP address here on this interface? We have 10.10.3 and then .1. Okay, 10.10.10.3.1. 24 submask. No shut. Interface fast Ethernet 1/0. IP address. This is the interface towards Office 2. 10.10.2.1. subnet mask 255.255. No shut. Okay, go back to enable command line. Let's verify the configurations we just configured. Show interface, show IP interface brief. Okay, we have configured these four IP addresses successfully, and as you can see, the links are up and running. The reason this is down and that is down is because we haven't configured router 5 and router 2. Okay, good. Back on router 2. Router 2 has 2 interfaces, one facing towards R3 and then the other one facing towards R1. Okay, so interface fast Ethernet 0/0 is facing towards R1. IP address 10.10.0.2, subnet 255.255.255.0. No shot. Interface fast Ethernet 0/1. IP address 10.20.0.2, 10.20.0.2, subnet 255.0. No shutdown. Show IP interface brief. Let's verify and see what we have configured. On router 2, that's good. We have both interfaces configured with IP addresses. Okay. R3, going to do the same. R3 has two interfaces, fast Ethernet 0/1 and fast Ethernet 0/0. One facing towards R4 and this one facing towards R2. So interface fast Ethernet 0/1, IP address 10.20.0.3 these three right here. Okay, 255. No shutdown. Interface fast. Now let's configure the one facing towards R4. IP address 10.20.1.3, 255.255.255.0. No shutdown. Show IP interface brief. We see that it's pretty well configured as well. Okay. Now let's configure R4. R4 has 4 subnets. One towards Office 3, this one towards R3, and this one towards R5, and then that one towards the public domain, the internet service provider. However, we're going to configure just these 3 for now. Okay. Interface fast Ethernet 0/0, IP address 10.20.1.4. No shutdown. Interface fast 0/1, IP address 10.20.2.4, 255. No shutdown. And then lastly, interface fast Ethernet 1/0. There's a typo. Interface fast Ethernet 1/0. IP address 10.20.3.4. This right here, 10.20.3.4. Okay. 255.255.255.0. No shutdown. Okay. Now we have configured all these interfaces on the routers. Okay, we should be good to go. One more thing before I forget. Let's make sure the computers are set up with the proper IP addresses. Okay, here 10 this IP address right here on PC1. Let's set it up on the computers. Okay, 10.10.1.11 subnet mask 24, so 255.255.255.0 default gateway. The default gateway for PC1 is this interface IP address right here. So it's 10.10.1.1 DNS server. Leave it blank for now. Okay, let's do the same here. It's already set up, so that's good. To speed up this lab, we went ahead and configured all these computers across our network in Office 1, Office 2, and Office 3. They're all configured. Alright? Let's verify whether there is any routes on these routers. Okay, the command for that is show IP route. As you can see, router 1 is locally connected to the 10.10.2.1 network. This is the network towards Office 2, and then it's locally connected to that network as well, which is towards Office 1, and then it's also connected to 10.10.0.0 subnet, which is this one towards R2. Okay, so that's good. If you check R2, it should be the same. Show IP, it's going to show you all the locally connected networks. Show IP routes. It's only got 2. That is, this one is towards R3, and this is towards R1, which is that and this. Okay, so that's good. PC1 should be able to ping any of these computers in Office 2. Okay, because they're locally connected to through this router. Okay, this router, it has routes to all these 3 networks: the network towards Office 2, the network towards Office 1, and the network towards R2. Okay, let's see if PC1 is able to communicate with, let's say, laptop 4 in Office 2. Okay, so ping 10.10.2.14, which is this laptop right here. So PC1, we're verifying and trying to see if PC1 will be able to send traffic across through router 1 all the way down to Office 2, and then we're going to see if Office 2, laptop number 4, if it's going to be able to reply back to PC1. Okay, there we go. The first ping dropped because the address resolution protocol ARP was updating, but you can see the next 3 pings were successful. So there's connectivity between Office 1 and Office 2. Okay, if you do it again, it's going to be 100% successful. Great. So this Office 1 and Office 2, they have connectivity to each other. Okay, now if you want to verify, let's verify and see which route the traffic took. Okay, the command for that is trace route. Let's trace route to 10.10.2.14. okay, we're going to trace the traffic and see which path it has taken to reach laptop 4 over in Office 2. Okay, as you can see, it says the first hop was at 10.10.1, and then the next hop was the final destination, laptop number 4, IP address 10.10.2.14. Okay, so the traffic has gone directly through router 1 and then down to laptop 4. Let's see if PC 1 is capable of communicating with any device in Office 3, say laptop 7 right here. Okay, open this command prompt line, ping PC laptop 7 here has 10.20.2.17, 10.20.2.17. Great. The reply back says that it was unreachable. Okay, we could not reach laptop 7 because we are in a different network that router 1 does not have a route to. Okay, the only route that R1 has is these 3 routes: the route to this network, route to that network, and the route to R2. It doesn't know how to go beyond these 3 networks. We're going to talk about how to configure our routers so that the traffic will be able to go from Office 1 across the network to Office 3. So this is where we're going to configure our static routes. Okay, we are going to tell router 1, router 2, router 3, router 4, router 5 how to forward the traffic to various sub-networks. Okay, now let's go to R2. Let's tell our R2 how to treat traffic that comes from R1. Go to R2. We're going to configure, although PC1 cannot send traffic across the network all the way to Office 3, laptop 7, these 3 computers, they still have access to this router. Let's verify that. Laptop 7, command prompt. Let's try to ping the gateway IP address 10.20.2.4. 10.20.2.4. Should be successful. There we go. See, it was 100% successful. Why is that? It's because this is a local network to this router. So a router has direct access to these PCs and these devices in this office, but router 4 does not know how to send traffic across these other routers to be able to reach PC1. And the same thing is here for R1. R1 does not know how to send traffic across this network all the way to R4. Okay, so that's where static routes come in play. Okay, we're going to configure static routes on all these routers, be able to forward traffic across this network. See you in the next video.